Hello everyone, welcome back. Today let's solve the 30th top coding intro question from 48 top coding intro questions created with Leetcode. We'll solve this problem using Python. This problem is related to a tree. So given a sorted array like this, the arrays are sorted from lower to higher. So if you see this array is sorted. So given a sorted array, we have to convert that sorted array to binary search tree. What is binary search tree? A tree which there will be a root node. All the elements in the root node left side elements will be less than the root node, and the right side element will be more than the root node, right? So again here the further subtrees will be again will follow the same thing. The left side node will be less than the root node, and then the right side element will be more. Sorry, left side element will be less than the root node, and the right side element will be more than the root node. The values. That's a binary search tree. So how do we? It's an array, right? It's an array. So what we have to do is we have to create a tree out of it. How do we create a tree out of it? We have to create one class which will have a tree will have a left node and the right node and then the value of the root node, right? So it is simple approach. So what we're gonna do is because it is a sorted, we can have a pointers where we can simply say we can start with a mid pointer, anything which as the name itself indicates, anything which is midpoint, right? I mean, it's because it's sorted, so midpoint can be a root node. If you see for this element for this data array, so they have given the example as they started with the mid, which is this 0, and the left side anything which is obviously it's a sorted, so anything which is in the left side will be less than this, so they all come in the under left side, and anything which is on the right side, the 0, right? So which is 0 is the mid value, which will come in the right side. This is what it is. So this can be rearranged. There is one more example. What they're saying is, so it's again a binary tree, binary search tree. So here the same thing. The 10 is the root node, and because it's a greater than 10, right? This value is greater than, it is lesser, right? This is more lesser. So this is greater than -3 is greater than -10. So that's the reason it is in the right side. The root is less than this, and then there will be any values which will be less than this. So say you can either follow this or this. That's what they are saying. The example, and there is one more example. This is what they are asking. So basically, what you have to do is we have to iterate through this recursively call a function and iterate through this list, and then form a try to identify the middle element. Once we identify the middle element, all the elements from here will be the left tree, and all the elements here will be the right tree. But again, this within itself is another tree, right? So again, we have to identify the mid element. From here, it will be, for example, this is the middle element. From once we identify all the elements here will be in the left side, and all the elements will be in the right side, right? But again, this what element goes again? This is the root node, and left side there will be elements, and the right side there will be. It's a subtree. So you recursively call this and then call the function. So I have a code here. Quickly, just want to show. It is very simple. So the main point here is I'll put a breakpoint and then show you. So here, this is the same. I've created copied the same code which is there in the Leetcode, which creates a tree node, the tree data structures. So I'm calling this function by passing this list. First, what I'm doing is, if you see here, first I'm checking if the numbers are length of the list, which is this list, which is if it is null, so you return none. Else, what you do is basically you take this number, mid number, right? Mid number. If you see this in this context, mid number is 2. So here 1, 2, 3, 4, 5. So it's an integer division, double slash, right? This is an integer division. So you take the mid element, which is 0, right? Which is 0, right? Mid element, mid is 2. Mid of, basically what you do is num of mid 2. So 2, 0, 1, 2. So start with 0. So you take a root, you take that, and then you make a root node out of it. You may basically take and then take a root node of it, and then in the left side, anything which is from in the left side, what you do is anything which is still here, from here till mid, right? Till mid, because mid is already covered till mid is. So this is a slicing operator in Python. So 0 till here, which means these two elements, you consider that as a right child, left child. So anything this you consider as the left child. So basically you will call this in the left child and you recursively call that element, right? So you're calling this, you create a node. Now you got a root node which is, which is 0, the value is 0. Now once you identify this, you recursively call the same function, but here in the first attempt we passed the entire list, but now we are passing only slice of this list. So 10 and 10, minus 10 and minus 3, so which basically recursively calls this again they divides the number. So if you see this recursively calls, now we have numbers which 10 and minus 10 and minus 3. Now this you again divide this, mid you get 1, so which is this. So out of this 0 1 minus 3, you create a minus 3 again a node which will be the left side, right? You call again the left side, you call this again the left side. Yeah, so you create a minus 3, and now you will be left with 10. So you again call till that element, you again call create a node out of it, and then you call the left function. So that's how you basically create I'll just show you here. You create a left node, left tree. So minus 10. So this is the parent node. This is how the tree looks like: 10, minus 3, and the minus 10. So the 10th left node is this, and the minus 3 left node is this. And once you complete this again, you have to, it goes back and clears from the stack all the callings, and then there will be a time it clears all the stack. Now the right side, right, once this was in the beginning, this was the list, right? You called this and then you went through the left side and right side of the sub list. Now there will be a situation where once you clear all the, yeah, so can you see this, the right side, it had called the right side of this. So the 5 9 9 will come here, and then basically these elements in the right side, it calls in the right side, you call these elements in the right side, and then 9 will be 9 will be the right side for the first, because it's the first element, because it's a mid plus 1, it goes to the mid plus 1. So the mid is 1. So this element 0 and 1, right? 0 and 5 and 9 between. So you start with 9, and then you come back to the left side. That is what it says. That's what it gives you the number. Basically, you start, the mid starts with 1. So which element has 0 and 1? So start with 9. So that's the reason you get in the right side, and the left side again 5. So this is how you create, and finally you will have a tree which will be like this. 0 is the root node, 5 minus 3 is the left side of child, and 9 is the right child for the 0, and minus 10 is the left child for this, and then 9 for 9 the left child is 5, and so on and so forth. This is how you create a binary search tree from a sorted array. That's all, guys. I think this is the same code, except the difference is because I'm calling these functions in the class, so I'll call this objects with the class with the self object. So it's basically an object for this class. So because this function is getting called within this, so self is nothing but object of this class. So I'm just calling with that object, and rest all similar. So this tree node, it is syntax of some of these things related to Leetcode I've removed to make it very simple in my code. But rest all the functionalities, if you copy this code, it should work automatically, nothing to be worried. But the arguments which I'm passing are less than here. You see these arguments, tree node, which are lesser here. I'm just passing the number which is anyway least. Here they are adding more syntax which I have removed from my code to reduce the complexity. But yeah, that's all. This solution got accepted. It's the same code. Simply you're just trying to find out the mid of the node, mid of the least, and then anything which is in the left side, you again create a left subtree. Again, you call recursively. Within left, you have left and right, and again right subtree you call. Again within right subtree, you again have a recursively call the same function left and right. and then once it is done, so you will return a root. So that is what the code is. Please try to debug and understand furthermore. If you want to read about what is a binary search tree, you can watch this video, which is related to valid binary search tree, to get more understanding. That's all, guys. I hope you liked it. Thank you for watching. See you in the next video.